It's something like 5 to the second power. So 5 to the second power. This is an exponent, okay? What do we call 5? If 2 is the exponent, what's 5? I would be the base, okay? So this is what we call an exponent expression or an exponential expression. Now, if you want to find the value of this, what do you do to find the value of this? What is 5 to the second?
It'll be 5 times 5.
That's right. So 5 times itself because the power is 2. So you expand it, we say 25. So basically, 5 to the second base power. What it means is not 5 times 2. It's not 10. A lot of people make this mistake. It's not 5 times 2. It's rather 5 times 5. 5 times itself twice because the power is 2. If we have 3 here, if the power was 3, then we would write 5 3 times here, 5 times 5 times 5. So we repeat the base as many times as the power here. This is what we call exponent power form. This is exponent form. And here, it's what we call the expanded form. That's when we break it down into multiplication. Basically, exponential expressions are just another way of writing multiplications. So instead of writing, for example, 5 times 5 times 5, I don't know, 18 times, you just say 5 to the 18th power. Or if you have, you know, a multiplication of 100 fives, 5 times 5, it's a very long expression to write. So instead of writing 5 100 times, you just say 5 to the 100th power. So this is what we call the expanded form. Expanded form. And of course, this is what after you expand it, when you multiply, you get the value. So 5 to the second, the value of that is 25. Okay, so that's basically an introduction to powers. You could also have something like this, 2 to the 4th power. What's the base and what's the power in this expression again?
The base will be 2, and the exponent is 4.
Exactly. What is the expanded form of this exponential expression?
It'll be 2 times 2 times 2 times 2.
That's right. So 2 times itself 4 times. It's not 2 times 4, it's not 8, but instead it's 2 multiply itself 4 times because of the power 4. And after you expand your expression, then you evaluate it 2 at a time. You don't have to multiply all at once. Usually that's...
Sorry, teacher, to interrupt you. I have to step off a little bit because they're doing something in my house, and but I'm gonna keep, on the Zoom.
Okay, just mute your mic until it comes back, okay?
Yeah, I'm gonna mute my mic.
All right, cool.
All right.
So 4 times 4, and that's 60. Okay, 2 times 2 times 2, that's basically the value, and so on. So we say 2 to the 4th power. So 2 to the 4th power. Or 4th power. Usually we just say 2 to the 4th, or 5 to the 2nd, or 3 to the 7th, and so on. That's basically how you evaluate and simplify exponential expressions. Now, sometimes you may have some negative exponents. But actually, I'm not going to talk about negative exponents today. Negative bases. Negative exponents for another time. So this number here, 5, is positive, 2 is positive. But sometimes you may see a negative there. For example, you could see 5 to the 2nd with a negative here. Or another example like this, negative 5, but this time with parentheses. So these are completely different. They both have -5 to the second, -5 to the second, but the difference is parentheses. So the outcome of these two is not the same. So if you look at the first one, so always try to identify the base and the power of the expression. So for this one, the base is 5, the power is 2. The negative here is not part of the base because it's not in parentheses like this. So the negative basically is independent of this number. So what you do is you write that negative first, then you evaluate this. So negative first, okay, not part of the base, then you evaluate this, so that's 5 times 5. And again, bring that negative over, and you multiply these, you get 25. The difference between this and this is that the base here is actually the whole thing inside the parentheses, including the negative. So when you expand this, you will have to multiply -5 by itself twice, or if you have 3 or 4 more times. Okay, so the whole base here is -5. So we're going to say -5, -5. You see how we repeated the negative because it's part of the base because of the parentheses. I repeated it twice because of the power 2. Now, if you multiply this, what do you get?
It would be positive 25.
Exactly. So positive 25. As you can see, it's totally different from the first one, which was negative. Because this negative was independent of the base. You just bring it over and you evaluate the expression. So that's an important thing when we deal with powers. We look out for parentheses. Okay, another example real quick. So what is -3 to the second? And also, what is -3 to the second? What's this one equal to?
It would be positive 9.
Right, because -3 times -3 is positive 9. What about this one? It would be?
Negative 9.
That's right. So bring the negative over, evaluate this, whatever it is, 3 to the second is 9. Okay, another thing also is when you have any number to the power 0 is what? Any number to
0.
not 0, but the rule for this, it's always 1.
1. Okay.
Yeah, so regardless of the number, any number raised to the power 0 is always 1. And also, similarly, be careful with the minus here. So if you have, for example, a minus here, negative, if you have these two, they're different. So these are again another problem. So when you look at this one, and again, whenever you don't see the parentheses, that just write that minus first. It has nothing to do with the exponential expression. So minus first, then you evaluate this. What's 2 to the power 0 again? 2 to the power 0 is just like this. Would be
It'll be -1.
-1, right? So the negative, you bring it over and you evaluate this. Actually here, we meant to put 0. So -2 to the power 0. So the whole thing is raised to the power 0. What is the outcome here?
Positive 1.
It will be just positive 1. That's right, positive 1. Okay, so that's basically an introduction to exponents. In college algebra, we discussed this in much more detail. But for now, that's all you need to deal with the exponential, with the order of operations. So now number 2, we're going to talk about the order of operations itself. The order of operations is usually we have maybe 3 plus 2. So that's one operation. We say that's 5. Or you may have 4 times 5. That's also just one operation. That's 20. Sometimes you may have more than just one operation in one expression. It could be 2, 3, or 4, 10, or even more. So we have to simplify that according to a specific order. That order is called the order of operation. It's not always start from wherever you want or whatever seems convenient. You have to follow a very specific order to get the exact same answer. Everyone should get the exact same answer for each operation. So let's say now we have an operation maybe with both of these combined. Say 3 plus 2, maybe another multiplication, for example, times, I don't know, times 6. So this expression, this arithmetic expression has two operations, the addition and multiplication. But to evaluate this, it has to be done in a specific way. So what do you think we do first to simplify this?
You'll do the multiplication 2 times 6.
That's right. So multiplication has priority over the addition. We're going to write the order later, but we all know that this has to be done first. So that's 12 plus 3. So we evaluate this first. The multiplication has priority over the addition. Now we can do the addition and we say 15. Another example would be, say, 2 times 5 minus 1. So now we have multiplication and subtraction. What do we do first again?
Multiplication.
That's right. So multiplication, we know for a fact that it has priority over both addition and subtraction. So when you sit them together, always look for the multiplication first. And that's 9. So the operation could involve more numbers, more symbols, and even parentheses. As an example for parentheses would be something like this. Let's say 7 minus 5 to the second power. And then maybe let's put a number here, probably 3. We have a lot going on here. Again, it has to be done in a specific order. So that order is what we call PEMDAS. We don't have to invent it, or we simply have to follow it. There's nothing here to think about. Whenever you see, should be PEMDAS. Whenever you see a bunch of operations together, you have to follow what we call, let me write that again. Okay, so they will call PEMDAS. Here's the order of operations. And we know that each one of those stands for something, right? What does the P stand for?
Parentheses.
That's right. Always look for parentheses in an expression if you have them. And if you have them, you do them first. If not, you move on to the next one, which is?
Exponents.
Exponent, exactly. Exponent is what we discussed here earlier. So E for exponents, and this is how the exponents are done. So this is for exponents, or powers, as some people like to call them. Then, after the exponents, we look for?
Multiplication.
That, exactly. M for multiplication, D for?
Division.
A for?
Addition.
Addition, and finally?
Subtraction.
Exactly. So that's the order we always look at. Doesn't matter how long, how complex the expression is, you don't have to think about it too much. Just think about the order of operations, write it down, and then follow it. So for example, for this one, always look for the parentheses. And when we say parentheses, we mean inside the parentheses, not this multiplication. We mean inside the parentheses. Do we have anything to do inside the parentheses? If yes, we evaluate that first. If not, we move on to the next operation, the exponents. Do we have to do anything inside the parentheses here?
Yes, we do 7 minus 5.
That's right. Obviously, we have a subtraction. So that's the first thing we evaluate is the parentheses. P here for parentheses. That turns into 3. That's 2 to the second. And again, right after the parentheses, we need to go to the exponents. The exponents, not the multiplication. A lot of people make the mistake of multiplying right now. No, it's not 3 times 2 yet, because we have an exponent. Exponents are done before multiplication. have to evaluate the exponent first. We got to evaluate this before we multiply by 3. So second step is the exponent. 2 to the second is 2 times 2. Just like this, 2 times 4. 2 times 2 is 4. What operation is here between 3 and the parentheses?
Multiplication.
Multiplication. So whenever you see a number followed by parentheses, that means that's a multiplication. Bring it down. And the final step is to multiply these two, you get 12.
And you get 12, yeah.
That's right. So this is only order. If you do it in any other order, you get the wrong answer. For example, if someone multiplied this first, 3 times 2, that would be 6. 6 to the second would be 36, which is totally different from here. So that's why we have to follow the specific order of operations. Now, let's do some more examples. Let's continue here. As we go, we're going to make the expression a little bit longer, more complex, and simplify it. So let's say 4 or 5 plus 2 to the third times 2 minus 1. So we have a lot going on here in this expression. But again, all we have to do is follow the order of operations. We don't have parentheses, so we go to the exponents. No parentheses here, so the exponent is here. We're going to evaluate this first. 2 to the third, that's 2 times 2 times 2, which is?
8.
8, right? Again, it's not 2 times 3. It's 2 times 2 times 2, which is 8. So you want to do your exponents on the side first and then bring the value here. So 5. Then write the whole expression again. Only do one operation at a time and bring the whole thing down as you go from one step to the other. It helps see the expression clearly and not get confused or miss the number. So always write the whole expression. Only evaluate one thing at a time. So here we evaluated the exponent. So after the exponent, if you go back here, we look for multiplication. Do we have a multiplication?
Yes, 8 times 2.
Right, so this is symbol for multiplication. It's not a decimal point. It's a dot, meaning multiplication. So it could be a multiplication sign here, or it could be this, or it could be just parentheses. As we said earlier with this, it was multiplication. So we're going to evaluate this. That's 16. So that's for multiplication. Again, bring everything else down. And this down. So now we have addition, subtraction left. Now the last two we evaluate in an order of operations. When we have them together, we do left to right. Whichever comes first out of these, it's done first. Okay, so even if the minus comes first, that's not a problem. So we do them left to right. So that would be 21 minus 1, and that's 20.
20.
Oops. Slippery. This thing is slippery. Okay, so that's one example. Like I said, if you have, let's do another example. It's at 15 equate 10 plus 2. So we only have addition and subtraction here. Again, even though it looks like the addition comes first here, we're not doing addition first. Always evaluate them left to right. Technically, they're about of the same level, so we do them left to right. So left means this, going to the right. So left to right. We're going to evaluate the 10 take away 15 take away 10, that's 5. Bring down the plus, that's a 7. If you do it any other way, do it the other way, you'll get confusing, especially with the minus here, 10 plus 2 or minus 10 plus 2. It can get confusing, so we better do it left to right to get the right answer. Same thing with multiplication and division. They're about of the same level, so when they're together, next to each other, we evaluate left to right. Even if the division comes first, we do it, we don't do multiplication first, we do left to right. So both of these and these, we evaluate them left. Okay, let's see an example of that. So let's say you have 15, again 15, maybe divide by 5 times 2. So if you're thinking of the order of operation, you might think, oh, the multiplication first and then the division. But no, again, these two are done left to right. This is basically an exception to PEMDAS. There's an exception here. So we're not doing the multiplication first, even though PEMDAS says so. But since these two are next to each other, they have to be directly next to each other, not one here, another one here. They have to be directly next to each other. So we do left to right. So we're going to give the left one and then the right one. So this is an exception here. Left to.
Oh, professor, so if division comes first, you will still go left to right.
Yes, just like
Okay.
addition and subtraction. So that multiplication and division. So it would be 15 by 5, which is 3 times 2.
So that's the only exception.
That's right, then that's 6. If you do this first, it will be 10, and 15 by 10, it would be 1.5. It would not be same as this, not same as 6. So we have to be careful with these exceptions when you evaluate. You may also have 4 times 2 division. Eight. So what do you do first here? The multiplication and division. Which one do we evaluate first in this example?
We're working left to right. So
Exactly.
would it be 4 times 2?
That's right. Always when you see these together or these two together right next to each other, you do the left one. Whichever comes first, you do that first. Only applies to these and this. Not if you have more things. So that's 8 by 8. And that's 1. What else? So let's take another example, a longer one. So 5, let's say plus 2. Okay, 8 minus, let's say 5 to the third, or maybe just to the second. And finally, multiply or divide division by, say, 2. So that's another operation with multiple operations here, as you can see. So again, always think about the PEMDAS. Another common mistake is when people do this first, just because it looks convenient, it's first, you just want to do 5 times plus 2. That's actually probably the last thing we're going to do is to add those two. So always follow PEMDAS with these couple of exceptions. So start from parentheses if you have them and work inside of them. So what we do first here?
8 minus 5, which gives you 3.
That's right. So only do one thing at a time. So that's 3. Everything else remains the same. And it's very important that you write the whole thing again. It makes things a lot easier for you and for the grader, people who grades and follows your work. So just one step at a time. So this is parentheses. So everything else is the same except for the parentheses. Now after the parentheses, we'll look for exponents. Do we have an exponent here?
Yes, 3 times 3.
That's right, we have this 3 times 3. So it's not 2 times 3 first. It's not the multiplication. Multiplication here is done after the exponent. So we're gonna do the multiplication after we're done with this. So we're gonna do this. That's 9. And again, just bring down all the other numbers. Everything else should stay the same. The 2, make sure you keep the multiplication here with the parentheses. Not just positive 9, you have to keep it the same. So a multiplication, keep the multiplication here with the parentheses. Bring the 5. What comes after the exponent? The multiplication, right?
So
And the multiplication here
is 2 times 9.
That's right. Here is the multiplication.
18.
So we can evaluate that. So we're going to put 18 here. And again, the rest of the expression should remain the same for now. So here we did the multiplication. Now we're down to 2 operations, addition and division. Which one comes first? Division is here. Addition is here. Obviously, we're doing the division first. Division is done first. That will be.
So 18 divided by 2 is 9.
That's right. Bring the plus down. So 1 operation less left. Finally, is the addition. As I said, this turns out to be the last one we did. So plus, that's 14. Again, if this is done in any other form, another method or steps, it will most likely be wrong. So always follow the order of operations with this.
Okay.
Okay, makes sense?
Yes.
All right. Hi, Laura. Now you just joined.
Hello.
Okay, so just follow along for now. I'll upload this later and you can rewatch it, okay?
Okay.
All right, so let's do one more. So order of operations sometimes can involve fractions. For example, you may see something like this. 3 times 2 to the second minus 1 over, let's say, 2 plus it could be a fraction like this, but basically it's the same thing. We do the order of operations. The only thing here is the numerator and the denominator are done independently. Each one has its own order of operations. We can do them simultaneously at the same time, but also independently. Each one is done on its own without interfering with the order of the other one. So start with the first one here. So what do you do first?
For the numerator, we're gonna do 2 times 2.
That's right. For the numerator, the PEMDAS, so it's going to be the exponent first before the multiplication. So it'd be 3 times
4 minus 1.
That's right. Then we go down to the denominator and start a new operation for the denominator itself, PEMDAS. What do you do first here?
What's in the parentheses, which is 5 minus 3, and we get 2.
That's
and
right.
then 2 plus 2. Oh, yeah.
Exactly. So we're doing this first. 5 minus 3, that's 2. You can put that in parentheses, but this is an explicit addition. It's not a multiplication. It's an addition, so it stays addition. Back to the top, continue with the order we started earlier. So what we do now, we have multiplication and subtraction. Obviously, we're going to do
Multiplication, 3 times 4.
That's right.
Get 12.
12. Take away
minus 1.
Back to this one. Only one operation left. That's
Get 4.
Final answer is 11 over 4. Doesn't matter if it's a fraction, that's fine. That's okay, just simplify it, reduce the fraction if possible. But it's okay for the final answer to be a fraction. You may end up with a whole number, you may end up with a decimal. For example, this is a decimal, this is a fraction, but that's all right, it's not a problem. Let's do one more example. So regardless of how long the expression is, basically the method of the order is the same. So one other example here is
Professor, do we have another section after this one?
believe yes. We're gonna have another one. We're gonna cover a couple of more things right after this one. Okay, so please rejoin. So let's say 2, 7 minus 4 to the third minus 3 and it's an example of another expression with multiple parentheses. But again, we're going to follow the order of operations here. So where do you start from?
What's in the parentheses?
That's right. So we have 2 sets of parentheses. So we can do both at the same time. We can do both at the same time because it's the same operation. We're going to evaluate this, and everything else will remain the same. So this turns into 3.
3.
To the third, right? Bring down the 2 minus.
Minus 3 parentheses 1.
That's right.
So
1
second
and
one.
second. Only did the parentheses, write the whole expression again. Now we're going to evaluate the exponents. Do we have them?
Yes.
Yes. So we're going to evaluate both of these. We have 1 here, 1 here. It's not the multiplication yet. It's not the multiplication. Again, multiplication comes after the exponent. So let's evaluate these and then go to the exponents. So that's 3 times 3 times 3 is
27.
27. Bring down the 2 minus 3. So 1 to the second is 1 times 1, which is 1. Okay, it's not 2. 1 to any power is 1. Even if it's 100 here, it still would be 1. 1 times 1 times 1 is just 1. Finally, 54. So now we can do the multiplications here. 54, take away 3, which is 51. And that's your final answer. Does that make sense, everybody?
Yeah, it makes sense.
Okay, very good. So let's start the second part. Second part, we're talking about some comparisons as well as some translations. We're gonna see some sentences, operations like these in sentences. We're gonna translate them into something like this and then simplify them.